Won't it be a good idea if we could control the speed of a DC motor? Recently, in our previous video, we have covered how we can control a motor both in the reverse and forward direction. And today, in this video, we are going to make an adjustable motor speed control using a 5.5 timer IC and a MOSFET. So, let me take you through. So I'm going to be starting with the 5.5 timer IC with 4 legs connecting pin 2 and pin 6 of the 5.5 timer IC. Place a jumper wire between the positive rail and the pin 8 of the 5.5 timer, which is the VCC, and then pin 1 to the negative rail, which is the ground. After doing that, I then place a 100 nanofarad capacitor between pin 1 and pin 2 of the 5.5 timer IC with a potentiometer, placing a 1 kilo ohms resistor between the ground and its first terminal. After doing that, I then place a diode in a forward direction. This is going to be the discharge path to the pin 7 of the 5.5 timer IC, placing a jumper wire between the pin 7, which is the cathode terminal of the diode, and also place the next diode in forward as I did here to the first terminal of the potentiometer. This is going to lead the direction of current flow connected with a 1 kilo ohms resistor between the positive rail. After doing that, I then place a jumper wire between pin 2 and the middle pin of the potentiometer. After done that, I noticed that the leads of the resistor was not really connected or in contact with the positive rail, so I had to take out from the second row to where we have our positive rail. After doing that, I then placed a 1 nanofarad capacitor between pin 5 of the 5.5 timer IC and then the second lead of the capacitor to ground. After then, I then place a RFZ44N MOSFET transistor, which is gate will be controlled by the 5.5 timer IC of the pin 3 output. Not early when I discovered I did a wrong connection by placing a 1K resistor here at this point, which it was not supposed to be at this point from the circuit diagram. I do beg your pardon. So I'm going to be placing that 1K resistor between the gates and the source of the MOSFET. This resistor is going to help to discharge electrons building up at the gate pin of the transistor. After that, I place another 1K resistor between pin 3 and the gate pin. It helps to protect the MOSFET in case it has to malfunction. The flywheel diode at the drain pin helps to prevent reverse current from the motor when switched off, and as you can see, it's being placed in the reverse direction. After that, I then plug in my DC motor for testing. One terminals of the motor goes to the drain pin and the other terminals to the cathode of the diode. Place a jumper wire between the positive rail and the diode and connect the source to ground, and plug in your supply voltage. And then if I should start rotating the knob, the motor should start rotating, but nothing to show. I noticed that the MOSFET was bad, so I then used this 4007 MOSFET in the place of the RFZ447. When I started rotating, the motor started working pretty well. And for more videos, links below the description box. And remember to hit the subscribe button for more videos next week, and remember to also keep your notification button on so that you'll be notified when new videos are being uploaded next week. Okay, let's see how this goes with this big motor.